Okay, Unit 8 in Algebra 1 was all about factoring. So this was our self-paced unit, and your process for factoring was guided through this flowchart. So first you learned about factoring out the greatest common factors, which is going to be your first step anytime that you're factoring a polynomial. Then we talked about grouping. Then we talked about our special products, perfect square trinomial and difference of two squares. And then we finally learned a method that will be your catch-all whenever you can't do any of these other things, which is the X factor. And now you're a little bit of a pro. You factored a lot. You probably realize that the two things you use the most are the things that I've starred here: the greatest common factors and using the X factor. So let's just kind of work through some examples. This first problem, I'm going to start with the greatest common factor, just like the flowchart says. So I'm going to take out a 3 from every single term. And then I continue factoring with what's left over in the parentheses. What's left over is not a perfect square trinomial. It's obviously not a difference of two squares, so I'm going to have to use the X factor. So on the top, I'm going to put 21 because that is A times C. The bottom, I'm going to put 22 because that is my B value. Remember, B on the bottom. Then I think of two numbers that multiply together to give me 21 and add to give me 22. So in this case, it'll be 1 and 21. So then I use those to split apart that middle term. So I'm going to still write 3k squared, but instead of 22k, I'm going to write plus 1k and plus 21k. Then I continue with writing plus 7. So I haven't changed the value of this expression. I've just reworded it of sorts. I've changed the way it's written so that now I can group it. So I'm going to take these first two, and I can take out a k. So I've got 3k plus 1 left over. And between these last two, I can take out a 7. So I've got 3k plus 1. And the goal here is for these two parentheses to match. So I did good. I know that we're on the right track here. So then I take out the thing that's in common, which is the thing in parentheses, 3k plus 1. And then I write what's left over, k plus 7. Now, the only thing I'm missing here is that greatest common factor we took out at the very beginning. So I'm going to move that down, and there is my factored form. That is my answer for this problem because they're wanting me to factor. Remember in Unit 9, if you've already learned that, that we talk about, no, not Unit 9, Unit 10, we talk about solving a quadratic, which is completely different. This is not solving, this is factoring, so I am finished. So here's another problem. Again, we're just going to go through this flowchart. So the first step is to look for a greatest common factor, which I do not have. This is not a perfect square trinomial. I can't group it. It's not a difference of two squares, so I'm going to use the X factor. On the top, I'm going to have negative 56 because that's 1 times negative 56. On the bottom, I'm going to have negative 1 because that is my B value. So then I think what times what gives me 56 and adds to negative 1? Well, I know 8 and 7 give me 56, and somebody's going to have to be negative, and it has to be the 8 so that when I add them, I get negative 1. Now, here's where you learned a shortcut. We learned that these two things now can be my factors as long as A is 1 in my original problem. So looking back up, right here we have this 1. That means I can go straight from the parts of my X factor to my answer. Okay? Now, if that weirds you out or you forget that trick, that's okay because you can still do it the other way, and that's what I'm going to show you now. I can still just split the middle term using those two numbers I created and then group the two pieces. So I've got n minus 8, take out a 7, and I've got n minus 8, and you'll see that it ends up being the same thing, n minus 8 and n plus 7. Okay? But the shortcut is there if you feel comfortable using it. Okay, so really quickly we'll touch on the two special products. I keep wanting to say perfect, but that's not true. The two special products we learned about. So difference of squares is the first one, and that is when you have a difference, a subtraction of two perfect squares. The way you factor it is to take the square root of the first term, so that'd be 2m, and the square root of the second term, which would be 5. And then you're going to write it with a plus sign in between, and then you write it with a minus sign in between, and you're done. Okay, I talked about how this is the shorter problem, so it gives you the longer answer. If you can't remember this, the X factor still works. It's just that you have to see that there is a 0 for your B value. Okay. So perfect square trinomials. These are a little bit harder to dissect, but they're very easy to factor. And I'm actually going to factor it first, and then I'll talk about why. So perfect square trinomial, you're going to take the square root of the first term, so that's 7n, square root of the last term, which is a 4, and then you're going to put it in parentheses and square it. This middle, the sign in the middle, comes from the B value, so this is going to be 7n minus 4 all squared. Again, I talked about how this is the longer problem, So I'm going to get the shorter answer when you compare these two. But again, let's dissect this just a little bit because not every trinomial is a perfect square trinomial. So the way you check is to first make sure that the first and last terms are perfect squares. And they are, because the square root of 49n squared is 7n, square root of 16 is 4. Now you have to check the middle term by multiplying these together and then doubling it. And 28 times 2 is 56. So this is a perfect square trinomial, so I can factor it like I did. Here's a couple of star questions that are factoring related. This first one is an example of a problem that you actually don't even have to know how to factor. You can just multiply all your answer choices. You can multiply these together and see if you get the original problem. For example, letter F would give us 28x squared plus 35x. Well, that's really close, but we're missing the negative, so I would know that F is out. You can also, though, just factor like you've always done. The first step in factoring is always the greatest common factor, and I see these both have an x, and they both have a 7. But that doesn't totally help me because if I look at my answer choices, they all have 7x. So instead, we have to play around with the positive and the negative. So if I take out a positive 7x, I'm going to be left with, negative 4x plus 5. But none of them say that. So instead, let's try taking out the negative 7x. I'm going to be left with positive 4x minus 5, which is the answer for G. Okay, but again, you could have just multiplied all those answer choices and seen if you got the original problem. So then this one is an example of a problem that you can't just rely on multiplication because you actually do have to factor. So they say, which expression is a factor of 21x squared plus 13x minus 20? Again, start with the greatest common factor. There isn't one. Move to grouping. Can't do that. It's not a perfect square trinomial, so I'm going to have to rely on the x factor. So on the top, I need to multiply a times c. So in this case, 21 times 20. So that's going to give me 420, and it's negative. And on the bottom, I'm going to put 13, and it's positive. Now, this is a big old number. This is where you would want to rely on your calculator to really help you out figuring out the factors of 420. I am going to take the time to do this one with you just so that you remember that it's not always going to be super easy. And I'm recording this video completely without practicing, so I really don't even know what the factors are going to be. So I'm going to over here write my factors. 1 times 420. In my calculator, I'm going to start dividing 420 by just whole numbers. So I know it's 2 and 210, 3, and we're dividing 140, 4. If this part's really boring to you, feel free to fast forward. 105. We could be doing this for a little while. 420 divided by 5. If someone already knows the answer and I'm not thinking about something, sorry. You can see the time up there. It is 7:47 a.m. Oh, whoa. Okay. 6 and 70. 7 and 60. Excuse me. 8 and 9 are not working. I can do 10 and 42, though. We're getting closer because the difference between these numbers is getting smaller. Let's see. 11 does not work. 12 works. 12 and 35. There we go. No, that's not it. Just kidding. I got so excited. Let's see. 13 does not work. 14 and 30. We're getting closer because the difference there is only 16. 15 and 28. Bingo, because the difference between those two is 13, finally. Okay? Now, again, I didn't know that that was going to be the answer, but you can see how long it took us to get there. There are a lot of factors of 420, so you may come across a problem that you have to do that. You have to list out all the factors. But now I know I can put 15 and 28 into my problem. I know one of them needs to be negative, and it needs to be this 15. So now I can use that to break apart the middle term. Okay, so I'm going to write 21, I'm going to move over here, x squared minus 15x plus 28x minus 20. So then I group the first two, and I can take out a 3x, and I've got 7x minus 5. Then on the second one, I can take out a 4, positive 4. So I've got 7x minus 5 over here. So then of my factors, I know that 7x minus 5 is 1, and 3x plus 4 is another. And you'll notice these things are all really close to my answer choices. So you have to look closely. The answer here would be B.